Everyday Books. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in the last video, we ended where now we introduced now notations of derivatives, right? Remember a recap, we said the first one, when you find the derivative of f of x, you'll say now f prime x, then you derive, okay? Then for y, you can say y prime or dy dx, depending on what the examiner gives you. Then this one, it is dx, then they will give you something here. Then you'll just simplify that. If it needs to be simplified, then you derive it, okay? Then this one, it is called dy dx, not dy divide by dx, okay? This one, it is called dy dx, not dy divided by dx, okay? Yes. So it is very important to know how to call that one, not dy divided by dx. You just say dy dx, okay? Good. Now let's look at examples now associated now with what? With rules. Now the first one we have 5x to the power of 4 minus 3x squared plus 2. So now, can I simplify this any further? No, because remember, before you can differentiate, make sure you remove square root to what? To this notation. Then the denominator, you remove it to what? To x to the power of, minus 1, like that. Okay? Before you differentiate, you want to make sure you do not have these. Okay? Good. Now, let's look at here. Do we have any square root or cube root? No. Do we have any denominator x? Remember, they say dy dx, meaning you are differentiating y with respect to what? To x. So it means any number that does not have x, it is a constant. Therefore, remember the derivative of a constant, it is what? It is 0, okay? Then let's look at this. We have what? 5x to the power of 4 minus 3x squared plus 2. Okay? So how do we derive this? Remember, you'll say dy dx, it is equal to. If you do not say dy dx, it is equal to, then you are wrong. You cannot say y it is equal to, because they say find what? Dy dx. Okay? Then remember, what do? We multiply this first. It's going to be 5 times 4. It is how much? 20. X to the power of 4 minus 1. Okay? Minus 3 multiplied by 2. How much? 6. X, then 2, you subtract what? 1. Remember, it's going to be 2 minus 1. Plus, remember the derivative of a constant. It is how much? It is 0. Okay? Then when I'm done, I have 20x cubed minus 6x. Like that, I'm done. Okay? Yes. Then number B, I have y it is equal to x cubed plus 7x squared minus 2x plus 4 divided by x. Can you see now? What do I have? I have this part. Okay? So what I can do, it is I'll try to remove this one. I have to simplify this. How can I do that? The first thing that you can do, remember here, we did not need to simplify, right? Yes. But here, since when you need to simplify, I'll just say y it is equal to. Then take this divided by that. There is this rule that says if I have a plus b plus c divided by d, it is the same as a divided by d plus b divided by d plus c divided by d. Let's apply that rule. So it's going to be what? Y is equal to x cubed minus x plus 7x squared minus divided by x. You can only apply this if you have only one term in the denominator. Minus 2x divided by x plus 4 divided by x. Can you see now we are still working with y? We are still simplifying y again. Now we are still simplifying y. What is this? This will be x squared plus 7x minus x and x will cancel, minus 2 plus, can you see this is the denominator? We take this one, the x at the denominator, we take it to the top. Remember, it is this one. Okay, this standard here. So we say it is 4x to the power of negative 1. Then now it is simplified. I'm in a position of saying, okay, what is dy divided by dx? Remember, I multiply this one to the front. It's going to be 2x. Then I subtract 1. It is like this. Plus 7x. It is 1. 1 multiplied by this one. It is just 7. Now, note, dy dx of a constant, it is 0. But dy dx of, let me do this, of a constant and x, it is that constant. What do I mean? If I have dy dx of 5, it is 0. But if I have dy dx of 5x, it is 5. Okay, why? Because check, it's going to be 1 multiplied by 5, it is 5. Remember, x, it has 1, then I subtract 1, it becomes 5x to the power of 0. And remember, x to the power of 0 it is 1, then 5 times 1 is 5. Like that. Then, where is, we are here again. Now, remember, I'm now differentiating. Minus the derivative of a constant number, it is 0. I do not need to write it. Then negative 1 multiplied by 4, it is negative 4. Right, x. Then negative 1 minus 1, it is negative 2. Then this is your final answer. Here, before you simplify this, you do not write dy dx. dy dx is going to be your final step. Why? Check here. Here it was already in simplest form. We just did what? We just applied dy dx, okay? Now the second one says find f prime x if you are given now f of x is equal to that, okay? Now let's look. If I'm given f of x equal to that, remember, I do not want to what? Square root of something. I do not want the denominator. Let's start by simplifying this first. It's going to be x to the power of 5. Can you see I'm still calling it f of x because why? I have to simplify it first. Plus 5 divided by x. This is the same as saying x1 divided by 2, x to the power of 1 divided by 2, divided by x plus 5 divided by 5 divided by x, right? When I simplify this any further, can you see this is, remember, rule laws of exponents says now when I divide the same basis, I subtract the what? The exponent. So it's going to be a to the power of m minus n. Can you see? So in this case, it's going to be x half minus 1. Remember, this is 1 here, right? Half minus 1, it is negative half. Like that, okay? Plus 5x to the power of negative 1. Remember, when you have x, you take it at the top, you have negative 1. Here, we do not take it at the top. We did, but now we can also apply laws of exponents, right? This is what I'm going to differentiate. Differentiate this, okay? When I differentiate that, I get what? I get, can you see now, when I differentiate, I say f prime x now, okay? Then remember, it is this one multiplied by the coefficient here, which is 1. It's going to be how much? It's going to be negative half x. Then negative 1 divided by 2 minus 1. Remember, subtract the exponent by 1. It is negative 3 divided by 2. Then 5 multiplied by negative 1. It is negative 5x. Therefore, negative 1 minus 1. It is negative 2. Like that. Like that. Okay. Now let's move on to number B. Let's look at number B. We have x squared minus x minus 6 all divided by x minus 1. Now, I cannot apply this rule that says a plus b plus c divided by d is the same as a divided by d. Why? Because now I have what? Two terms in the denominator, right? So what I might do, I'd say, okay, let me try to simplify the top part. So this is still f of x. I'm going to say, let me simplify the top part. So which is x squared minus x minus 6. Therefore, that simplifies very nicely, or factorizes very nicely to x minus 3. What did I do over here? Sorry about that. X minus 3, x plus 2. Divide by x plus 2. Can you see now? I see this is the very same equation, but now in the different version, right? This is still f of x, right? Therefore, I simplify, I say f of x, it is equal to, then I say, okay, this one and this one cancels. I'm left with what? F of x is equal to x minus 3. Then now, I'm in a position of what? Of deriving. Therefore, I can say f prime of x, because now this is simplified. Remember I said dy dx of something x. It is that number, okay? Meaning, if I dy dx of 2x, it is what? 2. Of 1x, it is what? It is 1. So here, the derivative of x, it is how much? It is 1. Y, you can say x to the power of 1, it is what? 1 multiplied by, when you take this to the part there, it's going to be 1x, then 1 minus 1. This is 1. What is x to the power of 0? 1 multiplied by 1, which is equal to 1. Like that. Then the derivative of a constant number, it is what? It is 0, minus 0. So it's the same as 1. Okay? Yes. Then dx, number 3, dx, you are given now what? On this one, you just say equal sign. Simplify this first. How can you simplify this? You're going to continue with this dx until you are done simplifying this one. Okay? It's going to be, when I simplify this, I have x, 6 and 4, x minus, and every time when the examiner gives you this one, this denominator is a factor. So this denominator is a factor in here, so that they can cancel each other. Okay, so I can say x. I said 6 and 2. X plus 6, x minus 2 divided by what? X minus 2. Therefore, this cancels off with that one. Okay. Therefore, can you see now I have what? Equal sign. On this one, do not forget the equal sign. It is an expression. Okay. It is not dx, it is equal to no. It is equal sign dx. Therefore, I have what? X plus 6. Then now, do you know if I'm in this position, is it simplified? Yes, therefore I'm in a position of deriving. When I derive, I remove this dx, okay? Therefore, what is the derivative of x? Remember the derivative of x, or something x. The derivative of this, it is what? 7. The derivative of that, it is 8. The derivative of x, it is what? 1, because we have 1 there, okay? 1 plus the derivative of a constant, it is how much? It is 0. So the final answer, it is 1. Like that. Okay? Yes. Let me have an example, last example, with regards to dx, that they may give us maybe a dx. Let's say we have, let's call this number b. Okay? Let's call this number b and say we are given now dx. I want you to see something, that there is nothing surprising here. Okay? Remember the first thing that I do, I say equal sign. Is this simplified? Yes, this is simplified. Okay, there is no denominator, there is no square root. Then I can say, okay, I remove this dx, because now I'm in a position of deriving this. Why? In this one, why did I not remove dx immediately because I had to simplify this first, right? But this one is already simplified, right? So what do? I derive this. I'm going to say 2 multiplied by theta. It is what? 2 theta x to the power of, then remember I say 2 minus 1, it is x, like that. Plus, here I multiply what? I multiply theta to the front, theta x. Therefore, here I'll have what? I'll have theta minus 1. Then we are done. This is basically that. Okay? Basically that's nothing difficult at all. Nothing difficult at all. Now, let's look at this exam type question. Okay? Let's look at that exam type of question. Then I'm going to have an interesting question here that we need to solve, that they might catch you off guard with. Okay? Okay. Now let's do 7.1. They say determine f prime x from what? From first principle. Why? Because when you know that you can see this, okay? If you do not see this, it is negative 2x squared plus x. Okay, now remember when you can apply rules and say, okay, this is 2 multiplied by negative 2 f prime x, it is equal to what? Negative 4x plus 1. Okay, but now they say to you using what? First principle. So if they say using first principle, can you see it is what? 5 marks. So you need to go into that first principle formula. But remember your expected answer. Should be how much? Should be negative 4x plus 1. If your answer is not this, it means you have done something wrong. So this is one of the way of confirming, for you to confirm that what we are going to do there on the first principle, it is correct. So now let's do that. Remember the first step, I just write what is f of x, right? F of x, I'm giving as how much? Negative 2x squared plus x. Second step, I want what? F of x plus h. It is what? Remember where I see x, I open a bracket and say x plus h. Then I square that, plus where I see x, I say x plus h. The third step, it is to want what? Remember these terms, all these terms on f of x should vanish, all of them, okay? F of x plus h minus f of x, it is equal to, oh, okay, we forgot to simplify f of x plus h. This is going to be negative 2x squared plus 2xh plus h squared plus x plus h. Negative 2x squared minus 4xh minus 2h squared. Do not forget this negative sign. It is very important. You miss it, you are out. Plus x plus h. Okay, then I can say, okay, f of x plus h minus f of x. It is what? What is f of x plus h? It is this one, negative 2x squared minus 4xh minus 2h squared plus x plus h minus what? Minus f of x. What is f of x? F of x, it is negative 2x squared plus x. Let's try to simplify this a little bit further. It is negative 2x squared minus 4xh minus 2h squared plus x plus h minus and minus is going to be positive 2x squared. Minus and positive is going to be minus x. Now let's see which one cancels off. I can see that negative 2x squared cancels off 2x squared, right? X cancel off minus x. Then I'll be left with what? Left with negative 4xh minus 2h squared plus h. Remember, do not forget that h. Okay. Then I'm in a position of saying, okay, I can come to my formula f prime of x. It is equal to limit as h approaches 0 of what? F of x plus h minus f of x all divided by h, which it is equal to limit as h approaches 0. What is f of x plus h minus f of x? This, we have simplified it. Okay, I'm gonna come here and just do what, substitute it here like that, like that. Then remember, my target it is to do what? My target it is to remove this h. How can I do that? I have to take out the common factor as h. Just take out h as common factor, leave out the negative, okay? Just say h is equal to negative 4x minus 2h plus 1. Divided by h. This is the same as limit as h approaches 0 of what? Of, can you see now this one? And this one cancels. It's going to be negative 4x minus 2h plus 1. Therefore, this is equal to, this implies that f prime of x, it is equal to what? When I substitute, okay, I come here and say substitute h is equal to 0, is going to be negative 4x minus 2 into 0 plus 1. So this is the answer. The answer is f prime x is equal to negative 4x plus 1. Okay, this is our final answer there. Now, is it true now? Yes, remember I said the expected answer should be negative 4x plus 1. So we are getting the same answer there of, okay? Yes. This is that. Then, okay, let's have this expression now. We have dx negative 5x there minus x squared divided by 5. Let me take that. Sorry, I want this. Okay, I only wanted that. Then I'm going to take this here so that we can solve that one. Okay. This is number 7.2.1. Can you see now 7.2.1, or rather 7.2 just says determine. Just says determine. Okay. So just says what? Determine. So now what exactly are we determining? We wanted the derivative of this one. Remember, is it simplified? No. Why? Because I have a square root of x. Square root, I have also what? A denominator. If you have square root of 4, or let me say square root of pi, this one you do not need to simplify it. Why? Because we are not differentiating with respect to x. To pi, I mean, we are differentiating with respect to x. So the one that we are differentiating with respect to is the one that is not supposed to be inside the what? The square root or denominator. So I'm going to say equal sign. How can I simplify this? I'm going to start first by saying, okay, let me remove this one like that. Okay. This 5, I'm going to leave it at the denominator. Why? Because now I'm not differentiating with respect to 5, but still it is not a constant. This is the same as saying it is 1 x to the power of 2, like that. Okay. So that you cannot, so that you do not differentiate this one. That will be a big mistake. Then now I need a little bit simplification, the last step. X, remember, if I have the same denominator, if I have the same basis, which is x and x, I do what? I subtract the exponents. It's going to be what? X. Therefore, this one, when I simplify that one, is going to be what? X to the power of 1 minus half. Remember, when the exponents are dividing, so when the bases are dividing and they are the same, we subtract the exponents. It's going to be 1 minus half, it is positive half, minus 1 divided by 5 x squared. Now, you're in a position of what? Of deriving. Why? Because everything is set. Remember this x here, it is here. Okay. Can I derive? Yes. Now, if you derive, you remove this dx and the brackets. Then it's going to be negative 5 multiplied by half. It is negative 5 divided by 2. Use your calculator. Do not become a mathematician. X. Half minus 1, it is negative half. Okay. Minus 2 multiplied by 1 over 5 is going to be 2 divided by 5x. Okay. This x, remember 2 minus 1, it is just 1. Okay. Yes. So we just simplified that. Let's look at the last one. dx. We are given d dx x plus 2 divided by x. Okay. Like that. Let's see. This is 7.2.2. So this is the same as this one, just that here they say d dx, right? So if that's the case, we're going to continue with this one. What do we want to do? We want to simplify our brackets. But can you see now I have difference of two squares? If this is x and this is 2 plus x, and this is x, this is 2 divided by x, so not plus x, divided by x. But what differs is the sign here. What differs is the sign. So I can say, okay, remember if I have a minus b and a plus b, what do? I say it is a squared minus b squared. Similarly, I'll say it is what? X squared minus, what is this? When I square this, it's going to be what? 4 divided by x squared. Like that. 4 divided by x squared. Then can I simplify this? No. Why? Because I still have x squared at the denominator, right? And I do not want what I differentiate with respect to, which is x in this case, to be at the denominator. So I'm going to say, okay, let me simplify this to what? X squared minus 4. This x, when it goes at the top, is going to be minus 2, like that. Then am I in a position of differentiating? Yes. So now I remove this d dx, right? When I simplify, this is going to be 2x. Can you see that 2 multiplied by 1, it is 2x. Then 2 minus 1, it is 1. Minus negative 4 multiplied by negative 2, it is plus 8x. Negative 2 minus 1, it is not 1. Negative 2 minus 1 is negative 3. Punch this on your calculator. Okay, yes. So this is basically that for differentiation. Rules of differentiation. The catch might come now when the examiner says, wait, let's try. Uh, Find dy dx if y it is, so if uh, y x plus 1 it is equal to 3x squared plus 4x plus 1. Okay, this is where now the catch is at. But remember, what does the examiner say? The examiner say derive y. So what you are deriving with what you are deriving, actually we are deriving what? Y. What you are deriving should be a subject of a formula, meaning now I should make this y a subject of a formula, meaning I should say y it is equal to 3x squared plus 4x plus 1 divide by x plus 1. Then now I can differentiate y with respect to what? To x. But now, can I do that now? No. Why? Because I still have this at the denominator. Okay? X is at the denominator. Now, what do? I say y it is equal to, I simplify this. How can I do that? Remember, I said at the denominator here, what they are giving you, it means it is a fact. So I can just forge other factors and say it is 3x plus 1. Okay, let me see, 3x squared plus x plus 3x plus 1 is divide by x plus 1. If you still do not know how to factorize, then we are going to have a problem. Then this one cancels off with that one, right? Remember when you cancel with a pencil during exam, then I'm left with y is equal to 3x plus 1. Therefore, dy dx. Why? This one is simplified. Therefore, I'm in a position of saying what dy dx. What is dy dx? Remember, 3x, it is a special case. Remember, when you derive 3x, it is just 3. When you derive 1, it is just 0 because y, because 1, it is a constant. Okay? Yes. Or the examiner can say find dy dx if now you are given y of okay, not y of let me say xy, okay, yx plus, okay, minus 2y, it is equal to now x squared minus 4. Okay, remember you are deriving y. You are deriving what? Y. So what should you do? You should take out y as highest common factor here. It's going to be y is equal to what? X minus 2. Okay. Your teachers do not necessarily show you this because, yeah, but yeah, it's fine. It is y. I'm taking y as a common factor, x squared minus 4. Then remember, I only want y, which is x squared minus 4 divided by x minus 2. Then now I say y, it is what? X minus 2, x plus 2 divided by what? X minus 2. How nice. Y, it is equal to this one. Cancel that one. Okay, can I simplify this? Yes, x plus 2. Can you see? Now, if this is simplified, is this simplified? Yes, I can now say, okay, dy dx, it is then equal to what? 1. Why? Because the derivative of x, which is 1x, it is equal to 1. The derivative of a constant, 2, it is how much? It is 0. So yes. So yes, that is what we need for what? For the differentiation now, how we learn how to differentiate. Now, let me touch up something, okay? Let me touch up something that is gonna need the of now we call that tangent for a curve, okay? The equation of a tangent to a curve. Good. Now, assume that you have what now? Assume that you have a function, okay? Assume that you have a function, yx, then maybe you have a graph that goes like, okay, let's name this f, okay? Now let's say you have a tangent to that graph. Remember, a tangent, it is a point that touches your graph how many times? Once. Oh, okay, okay. Now this is what we call a tangent line. So now, how do you find the equation of a tangent? Okay, how do you find the equation of a tangent? Remember, the first thing first, you need to find gradient. Let me say gradient of a tangent. The second step, find the what? Point of contact. What do you mean? Meaning here, the point of contact here, we want that one. Okay? Yes. Now, I want you to take some note of something. Remember, okay, this gradient here, like remember this formula is y is equal to mx plus c. I want you to take note of something. This gradient here, m, it is equal to what? The derivative of, remember, what is the derivative? The derivative is the same as the what? As the gradient. But this one, it is the derivative of the whole function, okay? But now we want what? The derivative at this specific point, okay? So how can you find the derivative of at this specific point now? We're gonna say, let's say the point of contact here, it is A, okay? It is A. So let's say this point here, it is A and f of A. Let's say that point it is A and f of A. Now, how can I find this gradient? This m, it is equal to the gradient of this graph, but where? Where? At A. Okay? When I say f of x, it is just the gradient of this graph. But when I say f of A, f of exactly the point of contact between the tangent and a graph, it is, I find the gradient here at this specific point. Remember, this gradient tells you about the gradient here. When you get f of x, you get the gradient of here, of there, okay? But now we need to know specifically we want where x it is equal to, sorry, where x it is equal to how much. So we want where x is equal to a. So that gradient, where x is equal to a, it is equal to the what? The gradient of a tangent. Of a tangent. Okay, now let's have an example. Let's have an example. Now, example. Okay, for f of x, it is equal to x squared plus x. Find the equation of a tangent. Find the equation of a tangent to f of x at the point 1 and 2. Now they are saying for f of x, you are given f of x, this is the function, okay? This is the function. Find the equation of a tangent to that graph of x squared plus x at this point, okay? So this point, it is the point of contact between what? F of x and a tangent. So let's try to redraw that. You do not need to draw the sketch. This is just me trying, I'm going to explain this like this. Let me make this a little bit broader. So this is f of x, right? So now we are told that we have a tangent to this graph, and can you see the equation of a tangent to f of x at point 1 and 2? So it means this coordinate where they meet, it is 1 and 2. So now remember we have equation of a tangent, it is mx plus c. Remember the first thing, what you need for equation of a tangent, you need what? The gradient of a tangent. The second one, point of contact. Okay, now we have this one point of contact, we have is 1 and 2. Now, how can I find the gradient of a tangent? I could find the gradient of a tangent if I had maybe a point maybe here and say use gradient formula, right? But now I do not have one. So what should I do? To find the gradient of the gradient of a tangent, remember I said you derive. You derive what? F of x. When you derive f of x, you get what? Let's see. This is x squared plus x. You get what? 2x plus 1. Remember, but this is just the gradient of the whole function. What you just found it is the gradient of the whole function. But now we want the gradient of this at a specific x value. Which specific x value? This one. Remember, this is x and y. At the specific x value, which is 1. So we want to know at a specific x value, which is 1, we get how much? You're going to say 2 into, remember the gradient of a tangent should be just a number, okay? 2 into 1, 1 plus 1. Then you get how much? You get 5. So, but remember, the gradient of a tangent, it is equal to the gradient of this, the derivative at the specific point, which is what? The specific point is the point of contact, which is what? It is 1. X is equal to 1, which is equal to how much? Which it is equal to 5. You see now I have what? The gradient, I have a point. So I can say, okay, y minus y1 is equal to m into x minus x1. I'll also use this one, y is equal to mx plus c, and show you that it works. What is y? Y is just y. Now, y, x1 and x, okay, you and I substitute the point of contact, which is what? 1 and 2. 1 and 2. Substitute 1 and 2. So it's going to be y minus, what is y1? It is 2. What is the gradient? This is the gradient of a tangent. Remember, it is how much it is? 5. X minus, what is x1? Remember, it is 1. Then it's just a matter of simplifying this. This is going to be 5x minus 5 plus 2. When I take 2 to the other side, it's going to be minus 3. So this is what we mean when we say find the what? The gradient of a tangent. Okay? Gradient of a tangent. Now, let's say you are given now, let's see. I want to find another example. Okay, this one is almost similar. Calculate the values of x where the gradient of g is equal to what? Okay, we are not given anything. Okay, I want a different one. Okay, let us have this one. Okay, they say for which values of x is the function y it is equal to x squared plus 3x minus 5 parallel to the line 3y plus 2x, it is equal to 6. Now, remember, for which values of x is the function this one, okay, parallel to the line, that one. Remember, for parallel lines, what do we remember about parallel lines? For parallel lines, the gradient of A it is equal to the gradient of B for parallel lines. Okay? So now, let's write this equation neatly. It's going to be what? 3y is equal to, take 2x to the other side, negative 2x plus 6. Then y is going to be negative 2x plus 6 divided by 3, which is just the same as y is equal to negative 2x divided by 3 plus 6 divided by 3, which is just 2. Okay? Can you see now I've written this formula in a new format? Just simplified it. Okay? Now, I want to know for which values of x is the function, this one, parallel to that line. Where this gradient, the gradient of this one, remember, for these two lines to be parallel, their gradients need to be what? Need. Remember, this is just for which values of x is the function? This one. This is the function. Okay, function parallel to this line. This is. Can you see? This is a straight line. This is just a tangent. Why? You see with this format, negative 2 divided by 3 x plus c. So it means now the gradient of a tangent here, it is how much? Negative 3. Sorry, negative 2 divided by 3. So now, if these two are parallel, it means now their gradient should be the same. But what is the gradient of y? Is equal to x squared plus 3x minus y. Remember, I said the gradient is just the derivative. So what is the derivative of this? So I'm going to say dy dx of what? Of x squared plus 3x minus 5. This is the gradient. It is equal to what? It is equal to 2x plus 3. This is the what? The derivative of a what? Of this function. Okay. But now I should equate it. Let me say for parallel lines, the gradient of a function should equal to the gradient of a tangent. Okay. Okay. Now, how can I do that? I'd say, okay, I have to equate these two. Okay, I have to equate these two. I mean, it means it should be what? 2x plus 3. It is equal to what? Negative 2 divided by 3. Now, can you say I equated the what? The derivatives, the gradients. Okay, I equated the gradients. Then I'm going to say 2x is equal to negative 2/3 minus 3. When I simplify this, it's going to be negative 9, negative 2 minus negative 11 divided by 3, right? Then I'll just divide by 2 by 2. When I divide by 2, I'll get negative 11 divided by 6. So this is the value of x. The value of x for which what? For which x squared plus 3x minus 5, it is parallel to that line. Okay. Let me see if I have the last one. The last one, maybe that's interesting. The interesting one, maybe if I have one here. No, I do not. I do not have anyone that's interesting. Okay. Okay. Let me try to create mine. Okay. Let me try to create mine, the last one. Let's say, given function given the function f of x, it is equal to, given the function it is equal to f of x, it is given the function, so given the function f of x is equal to, let's say, just keep it simple, 2x squared minus 4. Okay. Determine the value of x for which the tangent to the function, is parallel to the line, y it is equal to 2x plus 3. Now let's read this statement very carefully. You are given f of x, right? They say determine the value. Okay, I forgot something. Determine the value of x. Value or values of x for which the tangent. Can you see we are told that the tangent to the function is parallel to the line y is equal to x. Now we are told that the tangent, it is parallel to the line, this one. So it means now, if remember sorry, for now we do not know the equation of a tangent, right? Y is equal to mx plus c. We do not know it, right? But we are told that the tangent and this line, they are parallel. Okay, so if this tangent and this line are parallel, it means now the gradient of a tangent, it is equal to what? Remember, if two lines are parallel, they share what? The gradient. Remember, this is the gradient of the line parallel to the tangent. So it means they have the same gradient. So it means that the gradient of the tangent is going to be equal to what? To 2. That's the first thing that we have to take note of. The first thing. Okay? Gradient of a tangent, it is equal to 2. Okay? Why? These are parallel lines. Parallel lines. Right? Now that I know, remember what do I need for a tangent? I come back. I need a what? A gradient of a tangent, and I need a what? A point. But now they say I should what? Find the values of x uh, for which the tangent of the function is parallel to the line is equal to. Now that I know the gradient of a tangent is equal to that, what I need to do is find the gradient of this one. Okay, the gradient of that one. So the gradient of this one of the function is what? 2x squared. Sorry. So the gradient, the derivative of that function is 4x, right? I want to know the x coordinate where this tangent and this graph of f meet. I want to know if this is f and this is my tangent, y is equal to 2x plus c. Remember, it was parallel to a line here, like this. This was parallel to a line that had an equation of 2x plus c. Remember, for parallel lines, they share what? They have the same what? They have the same gradient. Can you see now the gradient is the same, 2x. Okay, let me not say but 2, right? Can you see? Hence, I concluded and said now the gradient of the envelope. Remember here it was mx. Okay, but now I know the m, it is equal to what? 2. Why? Because these lines are parallel. Okay, parallel lines. Okay, now I need this x coordinate here. Okay, I need that x coordinate there. So how can I get that x coordinate? How about I equate this f prime x here? I equate this f prime x here to what? To 2. Because at this specific point, the gradient is how much? It is 2. So I want to know which value should I input to x such that it gives me the gradient of 2. So I'm going to say, okay, for x, it is equal to 2. Remember, if I know this x value here at this specific point, I'll get the gradient is equal to 2. Okay? So now when I do my mathematics, I get 2 divided by 4. It is what? It is half. So here is the value of x, such that the derivative of a function at this point, it is equal to the gradient of a what? Of a tangent. Let's see if we are telling the truth. Let's test. We are saying the gradient of a tangent, it is equal to how much? 2. Right? Let's see f prime of x. It is equal to f prime of x, it is equal to 4x. Let's see at the specific point which we just said it is half. Is it now giving us 2? Yes, it is giving us what? 2. So can you see now they have the same what? They have the same tangent where at this specific point. Remember, I repeat, I said this tangent, when you just say f prime x, when you derive f, you get the gradient of the what? Of just this function, of the whole function. Okay, but at the specific point, you need the x value there. You need the x value there. Okay, therefore you get it. Okay, yes. So yeah, that's it. That's it for the derivative and what. Okay, tangent at a specific point as well as what. Okay, so now in the next video we'll be looking now at cubic functions, cubic graphs. Okay, we'll be now in a position of knowing how to do what, to sketch graphs, how to find the equation of a graph. Okay, and now how to do what, how to find many things thereof and analyzing a graph in particular. So yes, that will be us when we come back thereof. Okay. Yes.